Hey guys, it is August 13th and I'm about to do a replay challenge from Toby's Model Monday Live from August 12th, last night, my time. First challenge here. I've been doing the last couple of weeks and been a bit scratchy on these, so trying to pick it up today. Let's see how we go.
Show you the 2D print, you are going to try and turn it into a 3D model. So here we go. This first challenge begins in 3, 2, 1, go. What is the mass of this part in XXX grams? The tolerance is plus or minus 1 gram. Now, if you're here for the first time, you're going to want to grab a screen capture of this print using Windows snipping tool or MW Snap or Snagit or whatever screen capture software you want to use. Make the YouTube video full screen and grab a screen capture, and that way you will have everything you need because we are going to move on with this presentation. So grab a screen capture of this print. The unit system is millimeters, MMGS, millimeters, grams, and seconds. The material is ABS, and the density of that ABS is 1020 kilograms per cubic meter. So make sure that when you create this model, you are using the correct density. This model has some notes on it. We call these Toby notes. They show up in magenta. And these notes indicate that the arc and the line in the upper left view and top view are tangent. And these notes indicate that the tab, the little tab that's meant to flex when you snap this thing into place, has circular edges. So that should help you figure out what type of feature to use to create that tab. You notice those tabs have circular edges. It's got a radius of 45. The diameter or the max distance across there would be 90 millimeters. In the cross section, that's what the Toby notes are. Good luck to everyone. Welcome to everyone.
I should have listened to those questions, those points. Should have listened to what he was saying.
I'm going to leave this up here on the screen just for about 20 more seconds. You all have enough time to grab a screen capture. And then we're going to disclose the answer to this challenge in about 20 minutes. So you've got about 15 to 20 minutes to get this thing done. We'll see who is the fastest in the chat. You have to use all the drawing views. You have to use the isometric, the angled views. Really get all the info you need for this print, for this model. How fast can you take this and turn it into a 3D model? That's the name of the game here on Model Monday Live. So, like I said, so great to see so many people here in the chat joining us. Some new names, some new faces. Linux XFCE screen shooter. That's what Roberto prefers. I like it. Guys, don't forget to support the channel. I know you are frantically creating this model right now, so you can just kind of cut this away. But the easiest way to support the channel is to like and subscribe. If you're tuning in every week, you've probably already done this, but make sure you like the live stream. Make sure you subscribe. Make sure you share and reshare. We say it every week, but really you want to find that coworker who you think would be the most interested in 3D CAD. You want to kind of let them know. You can walk up behind them, maybe whisper in their ear. You know about TTT.com, you know about youtube.com/TTT. Let them know what we're doing every year, because you might have a CAD expert in your life and not even realize it, and you might just be itching for a challenge like this. So make sure that you let them know. Ram Bros Workshop has entered the chat. What's up, Ram Bros? Welcome. Thanks for joining us. We just started the first challenge. If you roll back the video just a few minutes, you'll see the first challenge.
Now this little tab thing. Tricky part. Okay.
A little bit more of a tricky challenge today. What was it today? Tier 4 is that we're looking at now? Yeah, Tier 4. I'll show this to you on the screen. Ram Bros. You got the screen capture. Tier 4 tab bush lead sleeve. Pretty cool little challenge here. Tier 4.
I like it.
Probably could be a Tier 5. It's kind of between Tier 4 and Tier 5, I think. Don't forget to support the channel, like and subscribe, share, and tell one coworker about it. And if you feel like you're getting a lot of value out of the channel, you always have the opportunity to provide some financial reinforcement. Keep the channel open. There's a super chat option here in the live stream down at the bottom.
Oh, we're nearly done.
Thanks if you're watching the recording.
That looks pretty good.
Visit the website, TTT.com/donate.
156.
Financial contribution. If you go to TTT.com/donate, you can set up something that happens every
Circular
month.
edges.
Say, listen, every month I get $10 worth of value.
Oh, it's a revolve.
I get $25
Okay.
worth of value on TTT.com. I get $1 worth of value.
Hmm.
I get
Okay.
$100. Value is different for different people.
Tricky.
Depends on, what you
Any answers yet? Gotta be close.
enjoy the show.
Will.
Different equations for each person. And if you feel like you're getting any value out of the channel, this is a great way to send some value back. Visit
Nope. Revolve, please.
make sure that
Can I go up to surface?
fully defined. They have everything you need on them, and they are good.
Thank you for the mention.
All academies are available. This is a great way to support back and kind of make sure that the channel.
Can I do both at the same time?
And of course, I want to say thank you to Dale W. and Sylvain. These are our regular monthly contributors. I'd love to see some more names on this list.
No.
So if you guys want to get your name on this list, this is a great opportunity. You can visit TTT.com/donate. Set up a
Can we
recording
mirror?
monthly
I'm not sure if we
donation,
can.
and we will get you on this list as well. All right, let's get into the world of TTT news. One of the biggest news things that's occurring right now is that we are hosting some training at the end of the month. If you're a SolidWorks
Bases.
user, if you're out there using SolidWorks and you want to get some training, we're going to be hosting a certified
No.
SolidWorks course. This is something that I worked very hard on. Really spent a lot of time kind of refining. I just retook the certified SolidWorks professional exam in 2023, so last year.
156. 156 at 15:32 in the chat.
Very confident that all the information you need for that exam.
2 minutes behind Will. I was pretty slow. And he was very quick.
And it's not just about, what is going to be on the exam itself.
All right, nice one. I think that's correct. Yeah, that looks really good. 45. Oh, have I got that right? Yeah, 45 tangent. Okay, that looks pretty good. We'll pause it there and wait for the results. Answer time.
Extrudes, but it's a matter of trying to figure out what to do with those circular edges, and I think you're going to need a revolve there to get those circular edges into the geometry that we're looking for with this challenge. So let's take a look here at what our chat had to say.
Yeah,
chat
need the revolve.
on Model Monday Live.
I should have. That's the bit that slowed me down a little bit.
So let's roll up here, and I saw an answer come in pretty quick from Will. 156, 156 grams. And then he revised to 156 grams. So we're sticking. You can answer as many times as you want during Model Monday Live, but whatever your final answer is, that's what you get locked in for. So Will 156 grams, locking it in. And Sharor coming in here. What's up, Sharor? Great to see you in here. 156 grams as well. Stu 3D coming in, 156 grams. Matt answering 156 grams. Nice job, and hello to Matt. Mohammed, our Katia user, coming in 156 grams. Bach 385, 156 grams, and Jonathan coming in here.
Nice work, Cole.
156
GG, Will.
Guys, the correct answer is 156 grams. Oh yeah. So
Very good.
Nice, Will. Haven't seen you here in a while. Just coming back strong. Blazing fire in 3, 2, 1, go. What is the mass of this part in XXX grams? You guys are challenged to take this geometry and turn it into a 3D model.
Nice.
Now, the original
2.5.
model of sheet metal, if you don't know how to do sheet metal, you could do it as thin features, as extrusions. You don't
Look at all those notes.
sheet metal, but you probably should. Sheet metal is the way to go for something like this. But if you don't know how to use sheet metal and you still want to play along with, you can kind of slug through it using thin features, and that is totally fine. So let's talk about some of the Toby notes on this one. This is intended to be sheet metal, so you can see right in the middle of the sheet, 4 millimeter wall thickness typical. All the walls are 4 millimeters. 4 millimeters. 4 millimeters. And
Am I going to regret this?
Inside bend radius. And that's also typical. Radius 6 inside bend radius. So all the inside bends are 4 millimeters.
What's the total height?
All the inside bends are 6 millimeters. All of the wall thicknesses are 4 millimeters.
It's not even
Where
shown.
things get a little bit tricky is recognizing the tangent bend line.
75 plus
top view, there's a
16.5.
tangent bend line. And that's kind of where that cutout, that notch to create the corner relief, that's where that cutout is located. So you kind of have to use that tangent bend
R6
line
inside.
that cutout, that notch. You can also see that the 50 millimeter angle
Thickness
flange,
4.
running up the back of this part, is directly collinear.
Total length.
Some of the other geometry, the side flanges that are going up, the triangular side flanges that are going up the side of this part. You know, in manufacturing, that would end up being welded together.
We're going to
We
go
got our first answer coming in from Big Dirty Cad. He just looked at it and said 499 grams. I'm not going to say if that answer is correct or not, Big Dirty Cad, but I will say you were the first one to answer. So well done. Well done.
if that's right, it'd be amazing.
So
16.5 plus
a very interesting model here. Good luck to everybody. There's
65 plus
the
90.
model are aligned in a logical way, in a way that they would be used for manufacturing. There's a 1 millimeter gap. There's a 1 millimeter gap between
Plus
the
174.
sidewall, the side flanges are going up.
I have no idea if this is going to be right. We're trying a little sneaky way of doing it. Like I'm going to try and draw the profile, you know?
It originally started. It originally starts at about 80 millimeters wide, and then it gets 5 millimeters wider to go to 90 millimeters wide. So, you know, where is that located? The answer is it's located where that tangent bend line is. So, good luck to everybody. This is a tricky one. There's a lot of Toby notes on this one for sure. You see Jordan coming in with an answer. Very nice.
These guys get it done already? Jesus.
867.5. I'm not going to say if that's right or not. I will say one thing. Generally speaking, I don't create models that have an answer that lands right in the middle of a tolerance. So if the tolerance is plus or minus 1 gram, I'm probably not going to give you an answer that calculates to 25.
Oh yeah, you're wrong.
I keep them a little bit more snug to the max range of the tolerance. So, just a little inside tip there for anybody who's going to be in tournaments.
Look, we're just taking our time on this because it is tricky. There are lots of notes.
Geometry that is very analytic, like this geometry, that should help you to know if you're going to be on the wrong track.
Yeah.
Cool model. Rich Penn in the chat says, what a fun tooling problem too. Yeah, thanks, Rich. Rich is the one who coined the term Toby notes. Anytime you see these
Toby notes, excellent.
They're kind of meant to help you analyze the drawing a little bit better. A lot of information here on one sheet of paper, but hopefully you're able to decipher it, and hopefully I didn't forget anything. Jordan says, it's Jenny's number, 8675309. How did I miss that? Of course, 8675309. Very good. There you go. I was once in a band that covered that song. I actually know how to play it. Alright, guys. That's going to do it for that.
It's 50 to the sharp.
Little visual.
But, yeah, I don't know. I still don't know where that point is.
You see, no challenges are fun. You know, the Ivan exploit makes them a little bit less fun. I can't really spend too much time putting holes in different locations throughout the model because the holes can kind of be anywhere. I think is what Bob Phelps is alluding to here. Real answer for the sheet metal challenge would be what's the CG of the flat pattern, yeah. And then that becomes tricky too because then you get into like K factor and bend reduction, bend allowance, and if there's any little nuances in the different CAD systems that cause those things to solve differently.
All right, well, we've got a defined shape.
I'll have to, really pad
Can we cut this?
Yeah, sheet metal is an interesting one. I think, flat pattern would be great if maybe I'll do some experimentation and make sure. K factor should solve the same way across any pad system, so maybe I'll do some experimentation and I could do flat patterns with a K factor, or like you said, CG with a K factor to help to make sure that we're getting consistent results across different pad systems.
It looks okay.
Bending, bending.
These is not right here.
If this corner here of the angled flange that's coming down, if that corner is too close to that bend, then that bend tends to kind of like wrap before the bend begins.
I need a tear here.
If the corner is down below the top of the
actually, no, I can just cut that.
We'll
do that now.
That corner where it's coming down, and even that could solve differently from one CAD system to another. So to try to keep it really CAD agnostic, I have to do things we might not do in the manufacturing world. Things like this relief here, it's so exaggerated. You probably wouldn't need that much relief, and it's just going to make welding more difficult. So, we do things different in the real world, but when we've got people using all different CAD systems, we want to try to keep it fair for everybody.
Fair is fair.
Build 123 has sheet metal, but does not have unfolding yet. The free CAD sheet metal stuff is pretty awesome, actually. Nice try. I like that. Multi-CAD disciplinary feedback. Very cool.
Can we use those contours?
Get your work cut out for you. Good luck on this model. For those of you who are just watching, I just want to remind you again.
Looks okay.
Is on Friday, October 18th.
And look, we're getting pretty close already.
Going out this week for all of the episodes. But when it comes to the tournament,
there's a big corner out in these sections.
We've got the schedule for the tournament listed at tutotoby.com/tournaments. This graphic
probably want to get that drawn in.
So what you want to recognize is that all these dates. You want to mark all these dates. Friday at 1 p.m. All these dates. Friday at 1 p.m. Friday at 1 p.m. Friday at 1 p.m. All these dates you can mark. But if you're competing, these first four here, these are all round of 16, round of 16, round of 16, round of 16. So we're only going to ask you to compete in one of them. We'll message you and say you've been selected for September 13th.
12.
So you don't have to compete on these other dates here. And then if you make it through September 13th to the round of 8, maybe we'll tell you you need to compete on September 27th. But then you don't need to compete on October 4th. That's the other half of the 8th. And then you need to book yourself for October 18th. And that one we're going to start later in the day. It's a Friday night. It's going to be, a bit of a party.
Any more detail on that one?
That one at 6 p.m. East Coast. That final episode. So all the other ones are going to start at 1 p.m. But the final one's going to start at 6 p.m. East Coast. It's going to be a party.
Perpendicular.
Final event. We're going to celebrate our new champion.
Just on the radius.
Champion. Unless Victor K makes a last minute submission to the leaderboard, you might have a repeat world champion. But we haven't had a repeat world champion yet, believe it or not. In all the tournaments that we've had different users from all over the world. So we started out with a winner from Canada using SolidWorks. Then we had a winner from the United States using SolidWorks. Then we had a winner from the Netherlands. Is that where German was from? Using Inventor.
I think that works.
Then we had a winner from the United States using OnShape. And then we had a world champion from the United States using SolidWorks. And during our spring open,
I'm struggling with that bit there. Maybe I should convert to sheet metal here.
A little bit of friendlier tournament. We had Airwick from Canada using OnShape. We have users from all over the world, winners from all over the world. We had winners using a lot of different CAD systems, or three different CAD systems. So OnShape, Inventor, and SolidWorks. What is the winner going to be using this time? Looks like not OnShape. It appears that the winner is not going to be using OnShape if we don't get any OnShape submissions. The only OnShape submission we have so far is
Already sheet. What do you mean? Oh.
Place. So I don't think Nikola Tesla is going to make it into the top 16. Although I do have some cleanup to do on this board. Some of these users are double and triple and quadrupled up. So I'll purge some of those. Maybe that'll be enough to put Nikola Tesla into the top 16.
Yeah.
But we need some on-shape users.
That corner.
Let's get some on-shape users.
That's the part that's really stuffed me here.
Love seeing these answers coming in. Victory Cat revising to 44. Ace coming in with 839. Will coming in with 765. So quite a variety
It's just
of
here.
answers coming in too. We still got about 10-15 minutes before we're going to show the answer.
I'm going to run out of time on this
So
one.
you guys do have some time here as I am demonstrating what's going on in on-shape. So let's go through and do an on-shape.
I just don't have that radius.
Live modeling here. I actually haven't really had a chance to look at this one or prep this
Oh,
one.
look, maybe if I do my bend flange up.
I'm going to go through and I'm going to try to come up with the mass of this model. See if we can't calculate it correctly.
Now we want to match this angle.
On maybe how to be a little bit more efficient.
Offset.
And then
I want to bend out.
Take a look at what the correct answer
Yeah,
is.
it doesn't want to create it. Shit.
So let me just make sure that I've got on-shape up and running here. Move this over to my other screen, get all logged in, and then we're going to do a live solve using on-shape.
Oh, cut.
Right here during these live solves, sometimes I get kind of zoned into what I'm doing in the.
Oh, I don't know if that's going to help.
So I might not be
maybe
attentive to the chat. If you guys need anything major, just spam the chat. Crazy's happening. Just spam the chat, and I'll recognize what you're doing. And I'll get in and take a look. All right, so let's get into it here.
Maybe like that.
This is our on-sheet 3D modeling. Actually, let me just delete that. I have a model in there that I was testing from earlier for this challenge that we're working on now, but
it's not quite right in the line, is it?
All right, guys. Well, with that, I think we're going to get into it here. Good luck on your live
offset
challenge. Not
0.5.
exactly an easy part there, that sheet metal part. But while you guys are solving that live here on Model Monday Live, we're going to jump into a on-shape 3D modeling tutorial.
Oh.
This is going to be a tutorial that's kind of for beginners here. This is called the left-hand bracket. Now, this is listed as a Tier 4 part, mainly because of the rib causing the need for some additional features. But I'd say this is probably right between a Tier 3 and a Tier 4 part. Not super complicated, but not super easy either. And the main thing that I always instruct my students to do when they're getting started with a 3D CAD challenge is to look at the 2D prints. Look at the thing that you're trying to model up. And that might be a 2D print like this, an engineering style print, or it might just be a napkin sketch. Maybe you've got an idea in your head and you're just going to kind of sketch it up and capture some of the key dimensions.
Oof.
But you want to take a look
that
at
doesn't look good.
And then start to imagine how you're going to model that. That process often starts with
I would really struggle on this one. And then comp, man.
Now the origin is the 0, 0, 0 in your model, and that
just makes it pretty tricky, doesn't it?
There's a lot of action taking place. And in the case of this model, I think that there's a lot of action taking place here at the center of this hole. And so that might be a good spot for the origin. You can see here it's 40 millimeters.
Not sure about using delete face on sheet metal.
It's 42 millimeters back here to get to the center of that hole. That might be a good location for
maybe
the center of the origin. Another location.
I'd be answering now as a guess. 7, 8, 9.
Or maybe even this corner here or this corner here of
at 45:30 in the chat.
Options as well, because these options here might represent what the first feature is going to look like. And the first feature is going to come up.
7, 8, 9. Let's look at our flat pattern.
The first feature is going to be this kind of L shape that you're going to extrude. And so maybe it makes sense for the origin to be there. So there's not always an absolutely correct answer as to where you should be. I think in the case of this model, it probably makes sense.
Missing some tabs here.
All the action is going to take place. You know, this part is going to get mated into an assembly, and it's going to get mated where the center is
some
here.
Tabs on that section.
And so I think it makes sense to have the origin located there, but you could certainly deviate.
1 millimeter gap per side.
It wouldn't be that big of a deal too.
Doesn't really say how long. I guess it goes to that edge. Okay. So this one here, we're going like this.
And this is where things maybe would get a
1 millimeter gap.
Because when it comes to creating the first feature of the model, you want to think about
and going in line with that.
You also want to think about what the overall footprint of the model is going to be. Now, I mentioned a moment ago that the very first feature certainly could look like this. It could be this shape here. You could create this shape.
All right, 8, 11.
It out to the full depth.
At 46, 46.
Here on this view. That certainly would work.
Still not sure if that would be right.
Down from the top. So we could create this shape here. That could be our first shape. And since we decided
and the slot. My slot's not round.
I think that makes sense to create that as our.
What happened there?
And so this is just part of the
I think it's
process
my cut.
from a 2D print to a 3D model. Before you
God.
even get started working in 3D, it's good to kind of think to
Come
yourself
on.
some different options.
800.
Paths that you can go down to create the model. Should I create the first
4720.
looking at this thing as like an L shape, or should I create the first sketch here looking at this thing as the footprint of the model? Where should the origin be located? How is that going to affect my decisions? And it's really
By now I would be out, no doubt. Like this is looking quite wrong around here.
So once you decide on what you're starting,
I just think all the tears are probably a bit off.
Now you're ready to start imagining what the rest of the model is going to look like. And so if this is going to be my first feature here, kind of straight, then I think my second feature is going to be this wall going down the side here.
It's very different. Like I feel there might not be enough detail in the drawing. You know, like to build it. So what was it, like 90 on the inside? 92. I don't think the 90s, that's not the inside, is it? That's the back edge, which I've got correct. That's 90. I'd probably have to do a drawing, so why don't we do that while we're here? Pivot, flange, tier 5. Because we can, I'll probably use this in the comp. Standard 3 view. You just don't have enough time usually to do this. Like I know angle's correct. That's correct. That's correct. Correct. 45 correct. Now sharp. That one and that one. Point. So that point to that edge, 90.2. So I'm off that on that. This one to the point 65. That's probably still okay. I think it's a center line between that and that. So that should be 14. That is, yeah, so I'm 0.2 off. It's not too bad, but 60, it's fine. 3 is fine. 65. Yeah, so that's off a little bit. Like that's probably enough to be wrong. 90. Oh, why is it R10? Man. Sheet metal. Thickness. Internal radius. Well, that makes a big difference. 817. 51, 55. 817. Still think I'm off. Can't believe I got that wrong. I've got the 1 mil gaps. I've got the overall size. Got the thickness. So that 0.2 difference there, I wonder if that's going to be the killer. 14, 14. Maybe this one? No, 80, that's fine. 45, 20. So, like, a lot of that's pretty good. Let's see if I can get that right. I can just change one of those dimensions. Will that fix it? Well, kind of. What does that make the 816.5? Yeah. So look, we'll pause it there. I don't know if I'm going to get any more accurate than this. I think a lot of people are having trouble. It's very tricky. Let's see what the answer is. Let's check it out.
This is a very tricky part, and I'm looking forward to doing a tutorial on this one at some point. But as we are running out of time here, let's take a look and see what our answers are. Big Dirty Cat came in with 484, very nice. Jordan came in with 8675309. Okay, Ace coming in 839. Will 765. Ace 808. Ace revising 833. Will 764. Sharor coming in 898. Ace coming in 822. Sharor revising to 816. Rand Bros 814. Very nice. Ace revising to 817. And the correct answer for this one is 817 Rand.
Hey, we're in tolerance.
We got it there at the end.
We got it.
Very nice.
Sharor.
GG to Ace.
GG to
Well
Sharor.
done. Here's coming in 801
Sharor.
grams. This is a very tricky part.
All right.
Very, very tricky.
Well done, guys.
There's
Awesome.
a lot going on this print, and it is not the easiest part.
Sharor has it, yeah.
No, Sharor has it. Oh, snap. You're right. I apologize. Delete message. Okay. And the correct answer
Sharor, what was your time, man?
817 grams, so it is none other than Sharor. Let's go. 816.98. Very nice.
I've lost this chat time.
Sharor, and GG to
Let me try and go back and
Sharor.
find it.
Very, very nice. Congratulations. Well done. Well done. My fillet command, and then takes me right back into the fillet.
Sharor
So I can just type in the
at 53.12, not quite.
See a rib in on. Now I'm gonna
55.
into circle, single click
09.
here. I'm gonna turn this into a circle with a diameter.
Congrats,
So
Sharor,
now
and
I can estimate
that's actually a win for me.
So it's
Man, that was really tough. So maybe I would have been okay in the champs. I'll put a timer on that in the edit and see how we go, but I reckon it's definitely over 10 minutes. So anyway, great challenges. Thanks very much. Looking forward to the comp soon. Cheers.